power, electrical energy, and efficiency. In this lesson, we're talking about electrical power, appliance power ratings, electrical energy, time of use, energy price, and electrical efficiency. So the analogy we can use for power is our sports venue for current and voltage. For current, it would be the number of people that enter per time interval, and voltage would be the amount each person pays to enter. Now that we've found the components, how do we calculate their total profit per time interval? Well, we need to take the number of people who entered the venue and multiply it by the price per ticket. This gives us the profit per time interval. This is the same for electrical power, which is measured in watts. So electrical power is going to be equal to the current, or the number of electrons passing by, times the voltage, or the amount of energy each electron has. So you see what we did here? We got our analogy for a sports venue, and we relate it to our power idea. Electrical power. Electrical power is the rate at which electrical energy is used. So power is going to be the current, so the number of electrons passing by the point, times the voltage, how much energy they give up. Just like the sports venue revenue was based on the amount of people coming in times the amount that they paid per ticket. The formula, as we said, is P equals I times V. It's measured in watts, and 1,000 watts equals 1 kilowatt. And generally, we're going to use kilowatts because most of our power ratings are pretty high. So here are some typical power ratings of appliances. So a clock's going to be really, really small, right? We said 0.0050 kilowatts. So if we move our decimal to the right 3 times, 1, 2, 3, we find it's actually only 5 watts. A clothes dryer is going to be 4 kilowatts. LCD TV is going to be 0.12 kilowatts. And then a ceiling fan is going to be 0.025 kilowatts. So you can see they don't use up a lot of energy. Now, if you take a look at the ceiling fan versus the air conditioner, you can see the significant difference. 1 kilowatt versus 0.025 kilowatts. And that's why using a fan to cool your home is much more energy efficient than using an air conditioner. Electrical energy. The amount of electrical energy used is calculated by multiplying its power in kilowatts times the amount of time it's usually used in hours. Household appliances typically have a label that shows how much energy we're going to use per year in kilowatts. So other examples include electric clothes dryer is going to be 900 kilowatt hours per year. Clothes washer, 400 kilowatt hours per year. Dishwasher 430, freezer 350, electric stove 650, and refrigerator 450. So you can see the things that use heat, our clothes dryer and our electric stove, are the ones that have the higher amount of energy usage per time. Now, how do we come to this kilowatt hour idea? Well, that's what we just talked about. So the electrical energy is the kilowatts times the time. So we get kilowatts times, in this case, hours. So that leaves us with kilowatt hours. Now, kilowatt hours per year is the amount that we're seeing in this column right here. So how much energy do we use? So our power times the amount of time we use it per year. So how do we calculate the cost of electrical energy? Well, the cost depends on the amount of energy used and the price you're charged for it. To calculate cost, you multiply the amount of energy used in kilowatt hours, like we just talked about, by the price, and it's usually cents per kilowatt hour. Many locations now also use smart meters, which not only track how much electricity you're using, but when you're using it, and the prices vary depending on the time of day. So for instance, in the summer, if you take a look at the left chart here, you'll see between 7 and 7, so 7 p.m. to 7 a.m., it's going to be off-peak. So it's going to be the cheapest time to use electricity. But between 11 and 5 in the summer, that's going to be your on-peak. And you can see that it's twice as much. So it costs twice as much to use electricity during those times compared to the off-peak. And then you have like a mid-peak hours in between. And then it changes depending on when it is. So weekends, statutory holidays, and then in the winter it changes again. So your total cost depends on how much electricity you're using as well as when you are using it, as I just said previous. And when you take into account these time of use prices, you can figure out exactly how much it costs to run the appliance you're trying to use. Check your understanding. A hairdryer has a power rating of 1200 watts. On average, it is used for 10 minutes each school day between 7 and 7:30 in the winter. What is the cost of using the hairdryer on all 5 school days for 1 week? Use the information below to answer the question. And when I say between 7 and 7:30, we're going to assume that it's 7 to 7:30 a.m. because we're going to use our hairdryer in the morning to get ready for school. So between 7 and 7:30 a.m. in the winter, you can see that that's going to fall right here to right there. That's going to be our on-peak time, or our 20.8 cents per kilowatt hour. Now, if the person used it between 6:30 and 7, then they'd get off-peak. So there'd be a difference there, which would be a substantial savings of money. So let's write down what we have. So we know that the power is 1200 watts. The time is 10 minutes per day. The cost is going to be $0.208 per kilowatt hour. And we're going to use it for 5 days. So I want you to pause the video now and try to solve this question. Okay, so how do we do this? Well, first of all, we need to convert a few things. We need power in kilowatts. So 1200 watts is going to be 1.2 kilowatts. Our time is 10 minutes per day. So 10 divided by 60 is going to be 1/6 of an hour times 5 days. So we're going to get 5/6 of an hour in our 5 days. Now 5 divided by 6 is 0.833. And then we got our cost already set up. So to figure out how much it's going to cost, we're going to take the energy used in kilowatt hours and multiply it by $0.208 per kilowatt hour. So we get 1.2 times 0.833 times 0.208. And that gives us 0.21. So 21 cents to use the hairdryer on those 5 different school days. So let's back up real quick and just show exactly what we did. So we need to find the cost. The cost is in kilowatt hours. This is the kilowatt. This is the hours. So kilowatt times hours. And then times the cost per kilowatt hour. So that's what we got, our 1.2 times 0.833 times 0.208. And that gave us 21 cents. How much more will it cost you in electricity over 1 year to use a clothes dryer for 30 minutes twice per week during off-peak versus on-peak? A typical clothes dryer will have a power rating of 4 kilowatts. So you're going to use the chart below here on the right to answer the question. So I want you to pause the video, try the question, and then we'll take it up. Okay, so we need to break this question into 2 different parts. We need on-peak and we need off-peak. And then we're going to compare the 2. And we're going to use a similar method we used just before. So the power rating, we know is going to be the same for both. It's going to be 4 kilowatts. We're going to use it for 30 minutes. So time is going to be equal to 0.5 hours. 5 hours twice per week. So times 2. That's going to give us 1 hour per week times 52 weeks per year. So that's going to give us 52 hours of usage for both examples. Now the off-peak is 10.1 cents and the on-peak is 20.8 cents. So to find our cost, we're going to take our kilowatts, which is 4, times the hours, which is 52, times the cost, which is going to be for on-peak 0.208, and for off-peak it's going to be 0.101. For on-peak, that's going to give us a total cost of $43.26, and for off-peak it's going to give us a cost of $21.01. So you can see a substantial savings. Now it's only $23 and change, but it is a savings and it does add up over time, especially when you take into account every other appliance in your house. Electrical efficiency. How efficient a device is tells us how much energy it produces/uses compared to how much it consumes. We can calculate efficiency using the equation energy output divided by energy input times 100%. So for example, a light bulb requires 200 joules of energy to light up, but only produces 100 joules of light energy. Calculate the efficiency of the bulb. So the efficiency would equal to the energy output, which is 100 joules, divided by the input, which is 200 joules, times 100%. So we'd be left with 0.5 times 100%, which would give us 50% efficiency. And that concludes our lesson on power, electrical energy, and efficiency.